Hello everyone, how are you all? In our last two videos, we saw bisection method and regular falsy method. In this video, we will be looking at another method of finding the root, which is Newton-Raphson method. So let's get started. At first, let us have a look at our algorithm. First, we have to find the first derivative of the function of which we have to find root. Next, we have to find a and b like our previous two methods in a way that function of a multiplied by function of b is less than 0. This function is the function of which we have to find the root. Next, we have to assume the value of x. We can take either value of a or b in x. Next, we have to find our root. Using this formula, xn plus 1 equal xn minus f of x divided by f prime of x. Now don't get confused seeing this n and n plus 1. It is written basically to represent the step and the next step. Next, we have to find x1, x2, x3 this way and continue these steps until we get roots having same value in two consecutive steps. Now let us have a look at our problem, then these confusions will get clear. So the question is, find the root of f of x equal 3x minus cos x minus 1 using Newton-Raphson method. So our given function is f of x equal 3x minus cos x minus 1. According to step 1, we have to first find f1 of x, which gives 3 plus sin x. Basically, we differentiated this function. Next, we have to assume the value of a and b. We can assume the value of a as 0 and b as 1. So, putting this value of a and b in in the given function, we get f of a and f of b, which gives us the value minus 2 and 1.46. Basically, we put this value 0 and 1 in the given function. So the product of f of a and f of b is minus 2 multiplied by 1.46, which is a negative value. So it's less than 0, which satisfies our given condition. So we can assume the value of a and b as 0, 1. If assuming values of a and b does not satisfy the given condition, you can change the values. You can try 1, 2 or 2, 3 this way. Next, let us create a table where we will write xn, f of xn, f1 of xn and a column for finding the root. According to our step 3, we have to assume the value of xn. We can take the value of either a or b as our xn. So we took the value of a in xn. Next, we have to find the value of f of xn by putting the value of xn equal to 0 in the given function 3x minus cos x minus 1, which gives us minus 2. Next, we have to find the value of f1 of xn by putting the value of xn equals 0 in the given function 3 plus sin x, which gives us 3. Now, putting these values in this formula, we got our root. Here, xn is 0 and minus f of xn is minus 2 divided by f1 of xn, which is 3. We just found it here. And we got our root as 0.67 from our step 1. In our next step, we will again put this value as our xn. So we put 0.67 in xn. Using the similar process, we have to find the value of f of xn by putting 0.67 in the given function 3x minus cos x minus 1, which gives us 0.23. Next, we have to put the value of xn, which is 0.67, in f1 of x equal 3x plus sin x, which gives us 3.62. Now we will put these values in this formula to get our root. Xn minus f of xn divided by f1 of xn, which is 0.67 minus 0.23 divided by 3.62, which gives us 0.61. Now we will use this 0.61 as our xn in our step 3. So we wrote xn as 0.61 in next step. Next, we have to follow the similar process to find f of xn and f1 of xn by putting the value 0.61 in these two functions. So we got 0.01 as our f of xn and 3.57 as our f1 of xn. Putting these values in the given formula, we got 0.61. You can see the value of xn is 0.61 minus f of xn, which is 0.01, divided by f1 of xn, which is 3.57. This gives us 0.61. Now if you look at our roots, you see we have got roots having same value in two consecutive steps, which is 0.61. So that is our final root. So our actual root of this function is 0.61. and using earlier two methods we also got this same value for this function as root. So you can say that whichever method you follow, the root will always be same. So that's it for now. If you don't understand, just go through the video again. Thank you.